I'm Miriam.
And I'm Rose.
And today we'll be introducing to you guys
Microtubules.
So before we can start talking about microtubules, we're going to talk about the cytoskeleton, which is made up of protein fibers such as actin filament, intermediate filament, and microtubules. But in this video, we're going to focus on microtubules, which is the green structure in this picture. Microtubules are long, hollow tubes made up of tubulin, alpha tubulin, and beta tubulin. And this right here is a cross section as to if you were to have cut the microtubule, you would notice that you would only see one color. For future reference in this video, we're going to be using green and yellow beads to refer to alpha and beta tubulin. Together, alpha and beta tubulin become tubulin dimers. Together, alpha and beta tubulin become tubulin dimers. They play an important role in eukaryotic cells, such as cell structure and supporting the cytoplasm. Okay, and in a microtubule, you have a plus and a minus end, where you can grow and shrink tubulins. Basically, the tubulins would grow from the plus end and it would shrink from the minus end. We will get to tubulin dimer GTP and tubulin dimer GDP later on in the video. This again is a cross section of a microtubule, and you can see the plus and minus of the beta and alpha tubulins. You will always find on the plus end beta tubulin and on the minus end alpha tubulin. Okay, so there is something called the microtubule organizing center, which is where the microtubule is anchored to a microtubule organizing center and it grows from the plus end. An example of microtubule organizing center is the centrosome, spindle poles of the mitotic spindle, and basal body. So in a centrosome, you can see that the microtubules are attached to the centriole, where they're anchored to the centrosome and they're growing out from it. So it's anchored and they will grow out from chromosomes. In a centrosome, a centriole is made up of 27 microtubules, which in mitosis, the centrioles duplicate and act as an anchor for microtubules during anaphase, when the centrioles become shorter to separate the chromosomes. In a basal body, flagella and cilia is made up of microtubules in a 9+2, because you can see 9, these add up to 9, plus 2 microtubules. The dynein help microtubules move past each other, which drives the movement of the flagella or cilia. So these are the beads that we will be using in our next skit, where the green is beta and red is alpha tubulin, where the green will be beta, which is the plus end of the microtubule, and red will be the alpha tubulin, which will be the minus end of the tubule. And together, they will be called tubulin dimers. This is a protofilament of the microtubule. One by itself is called a protofilament, but if you were to have added on extra, such as this, it will then become a hollow tube called the microtubule. If you were to have cut the microtubule, you would only see one color, and on this side we're showing you the beta cells, which is the plus end of the microtubule.
I'm going to explain to you the dynamic instability of microtubule that is driven by the GTP hydrolysis. Tubulin dimers carrying the GTP, which is on red, is band tightly to one another more than the GTP dimer that carry the GTP, which is an dark green. Therefore, the dimers of the dimers is added freely on the end of the DTP tend to go very rapidly. Then the GTP, therefore, rapidly growing plus end of the microtubule will have freely added tubulin dimer with the GTP bond tend to grow very fast, which it result in a growth. However, from time to time, when the microtubule is slow, the dimer of the GTP cap will hydrolyze the GTP to GDP. The GTP cap is therefore lost. Because GTP carrying dimer are less tightly bound in the polymer, the polyfilament peel away from the minus end and the dimers are released, which is causing the microtubule to shrink.
As I was explaining, the dynamic instability of the microtubule driven by the GTP hydrolysis. The GTP dimers carries GTP red, bend tightly to one another, then do the GTP green. Growing plus end of microtubule, we have freely added tubulin dimers with GTP bond, tubulin dimers with GTP bond. They have GTP bond between them, tend to grow faster, which will result in the growing part of the microtubule. It has a growing part of the microtubule. But from time to time, if microtubule is slow, the dimers of the GTP cap will hydrolyze the GTP to GDP, and GDP cap will lost. GDP cap will lost, and because GDP carrying dimers are less tightly bound, this one they have GDP dimers, they less tightly bound. They're not really very tightly bound. So the polymer or the protofilament is peeling away, resulting in a shrinking